Hi everyone, we continue to discuss the transient simulation capability. A piecewise linear voltage source is introduced. Once again, a RC circuit is taken as an example. This is the way to specify a piecewise linear signal. In this case, the quantity should be pulse. Then a spec array is recognized. The array is an array having several pairs of time and voltage. For example, the first pair 0, 0 represents that the voltage is 0 at time equal to 0. It is still 0 at 2 nanoseconds, but at 3 nanoseconds, the voltage becomes 1 volt. Between 2 nanoseconds and 3 nanoseconds, the voltage linearly varies from 0 to 1 volt. So, this array specifies a piecewise linear signal. There is one thing to be noted. The time variables must be sorted. As you can see here, the time variable monotonically increases. If they are not ordered, the simulation result may be wrong. When you learn the previous example, we get this waveform. It is a 100 MHz signal because its period is 10 nanoseconds. How about its rise time and fall time? Each of them is about 10% of the period. Of course, the real signal has a smoother transition, but for simplicity, we will use this simplified piecewise linear waveform. Consider the RC circuit whose RC time is 1 nanosecond. In this graph, the red curve is the output voltage. The input frequency is 100 MHz. We can consider two extreme cases, a low frequency and a high frequency. This square waveform has a DC component of 0.5 volt. Also, it has a non-zero component at multiples of the fundamental frequency. When the fundamental frequency is low, for example, 10 MHz in the upper panel, even its harmonics are within the passband. Therefore, the output signal, the red one, just follows the input signal. On the other hand, when the frequency is high, 1 GHz in the bottom panel, only the DC component can pass without much loss. So the output approaches to 0.5 volt and the amplitude is much smaller than the input signal. Now let's move to the CMOS inverter. Depending on the fan out, the load capacitance can be different. In this time, we use an estimated value of the fan out capacitance 0.167 femtofarad. Of course, it is related with the case of a single CMOS inverter. This figure shows the input and output voltages at 1 GHz. With the minimal load capacitance, the propagation delay times are quite short compared with the period. Of course, since the P MOSFET is a little weaker than the N MOSFET, the output transition from 0 to VDD takes longer. Now, you can increase the load capacitance, or you can increase the operational frequency. It's your exercise. Okay, that's it for this lecture 17. Now, you can simulate the time-varying characteristics of a simple circuit. Basically, you are now ready to start your own project. In the remaining lectures of this semester, I will consider some examples and tips for your projects. Thank you and see you later.